Yo. Okay, we're hopping out here, one-footed, we're in the boot. We're talking about RAG pipelines. So RAG stands for Retrieval Augmented Generation. This is a technique to kind of give context to an LLM or your LLM agent. So RAG pipeline. Chunk broke. So when we're normally prompting LLMs, like using ChatGPT's API or just using their UI or their website online, what you're doing is you're prompting the model, right? This is the model. We'll just use what, like GPT is GPT-5 now, for example. As a user, you are giving it all the information, right? And this is just a normal LLM. So I'm giving it a prompt right here. Maybe if I'm smart about my prompting, if I'm trying to engineer my prompts, I may be giving it context, some context. So maybe, I guess, usually you use a RAG pipeline to write code. So maybe I'm copy pasting some functions in my code. But this takes a while, right? Because I got to figure out what code I want to put into the model. And so where a RAG pipeline is helpful is it kind of automates that process. So in the name, Retrieval Augmented Generation. So how that works is you take your entire code base, right? Let me erase. You take your entire code base. So let's say we have a bunch of different files. We have all our files in some directory. So this is just like a project directory, and then maybe we have like source, and that's pointing to all these files. Kind of the first step in making our pipeline is embedding our context. Our entire project is our context, right? Because we're trying to use the LLM to generate new functions, new code to add to our project. So we need the project as context. So how this works, there are a lot of free open libraries to do this. Do a vector embedding. So we take all these files, turn them into vectors, turn them into just a bunch of numbers that kind of represent what the contents of the files is, and then we just put it off to the side in an index. So let's say in our folder, let's say we have a project for our RAG pipeline. We maybe have like our project folder, and then we have like our main.py, which is going to actually run the workflow, and then maybe we have a bunch of scripts that vectorize all of our context, and then we have our index, and in our index is where we'll put all of our files. And these are all vectorized, ready to go. Doesn't take up a lot of space. And so the next step is we can actually prompt our LLM. So let's say we have our agent right here, or our model. Here's our model, LLM. When we're prompting it, we're gonna give it just a natural language prompt. But what a RAG pipeline does is instead of just immediately sending that prompt right here to a large language model, first, it actually vectorizes it just like our context. So now turns it into a vector, and then it compares it with all of our index, all of our vectorized information. And whatever in our index matches this prompt vector well, it actually pastes into the prompt as context. This is completely automatic. As a user, you're not seeing any of this happen, ideally. You're just giving your prompt. You're saying, okay, fix this specific function, vectorizes it, compares it against the index, pastes that function as context without you having to do anything, and then gives it to the LLM. And this way you're gonna get much better output. You're giving it a very structured prompt with examples, and you don't have to think about it at all as a user. So this is very powerful. Yeah. Now we're gonna get into limitations. Okay, bang. We're back. So, RAG pipelines, again, very useful. You have to use them the right way and with the right models. So, it's very tempting, I think, especially when you're using a RAG pipeline, to want to really like maximize the efficacy of your model, of how it's generating. So you might want to download like a local model, right? And for some people, that's pretty feasible. Some people have very nice personal computers or workstations with pretty high-powered GPUs, a lot of RAM. So you can run 7 billion, 20 billion parameter models fine. I'm working on a MacBook with an M3 chip, and it is struggling with a 2 to 3 billion parameter model. So right now there's a couple ones I was looking at. I think like Code Llama, I think 2B, and then also DeepSeek Coder. I think like 1.3B, just 1.3 billion, 2 billion parameters. And so I'm just following that pipeline on my MacBook, right? I take this model, I vectorize all my code. I think I was doing like a React project or something. So the actual vectorizing part's very fast. The libraries are very optimized for that. But once I paste my context into one of these models with my prompt using my pipeline, it's taking me about like 2 to 3 minutes locally to generate a response that is like 1,000 tokens. And for reference, these models both have a context window of under 10K tokens. I think this one's like 8K and this one's 4K. and that's teeny. Like ChatGPT, just the free version, has a context window of 128K, and I'd say that's very large for being free, but for the amount of context you're putting into a model with a RAG pipeline, that's not a lot. And if this is like your context window and you're filling it up to right here, this is the amount of output that AI can give you, right? So with a RAG pipeline, you're overloading on context. Like, there's much more context than you normally put into a model when you're just normally prompting it. So if these models right here only have like 4K context, like 4K token context windows to begin with, they're not going to give me anything back, especially in a timely manner when they're running on maybe a CPU or some chip with like an integrated graphics card. It's not good. But there are some ways we can make it much better and much more efficient, which I'll get into. Okay, how can we make these models better and really adjust for like performance or hardware limitations? And so there are a couple things you can do when you're working with limited RAM or limited computing power. What you want to do is really you can either make your model better and faster, or you can give it better context, so you can give it less context and save it from having to take in all those tokens. And so one thing you can do that's pretty easy right off the bat is most models offer a quantized version. What that means is like the model weights, instead of being like, I think it's like unsigned 32, like U32 ints, it chops them off, it like truncates them to like unsigned 4-bit integers or 8-bit integers. And it does it in a very smart way. So when these companies are like producing these quantized models, they're very smart about what weights they truncate, and they're able to reduce these models in size and like memory by like 75%, but performance drop is very minimal. So that's one way. So you can get the quantized version of a model and have it be a lot more efficient on less powerful devices. Another way is if you have all of your context, like all of your files, instead of vectorizing them file by file, so each time like a prompt vector like matches one of these files, you're going to be pasting the entire file's context. What you can do is actually chunk the files. It's called chunking, and then maybe take like 500 character chunks, 1,000 character chunks, and split them up in each file. And so that way you're not taking the entire file when you match a vector. When like your prompt vector matches with one of the chunks, you're just taking a chunk here and then a chunk there. So this is something you should probably be doing anyways. That gives you much more relevant context than just like pasting the entire file. But this saves you a lot of space on your context window. You can take it from here back to here and get more room for your output and other prompting. So that helps. And then another thing you can do is just obviously upgrade your hardware. I think if I were to use, I have like another computer with like a 3090 in it. So if I were to use that, I probably could get away with using like a 7 billion parameter or a 20 billion parameter model. But the output still wouldn't be great. And so even with all these things, using the 2 billion, 3 billion parameter models on my MacBook, I wasn't able to get any like relevant good output. It would be much more efficient for me to still go to ChatGPT online or just use some paid AI that's accessing like a data center via an API and manually copy paste my context there. But there are other ways you can do it on a computer. Can't do it locally, but you can be smart about it. So we'll talk about those. Okay, yeah. So despite those limitations, I'm just showing you kind of what my setup is right now. There are a lot of tools, free tools online that you can download that aren't local agents. So there's some paid examples. I think, well, there's a difference. Like Cursor and Windsurf are IDEs that can help you with code completion. And then there's Claude Code, which is an agent that helps you. And then there's Google Gemini, which is a free agent. And so what I have right now is I'm going to open Gemini in one of my projects. So I'm just going to go to my project right here. And then I've got a bunch of stuff waiting in this project. And then I'm just going to open Gemini, get it going. So this is it's Gemini CLI command line interface. And this is me prompting it. And this is really cool. So this is an agent. This is fundamentally different from a normal large language model because it has agency. It has access to tools, which means it can write and read files. It can access GitHub. It can communicate with stuff, via APIs. And so this is very powerful, and you can make it even more powerful by using a RAG pipeline. So in this other window here, I'll make this bigger here. In this other window, I'm gonna go into a folder I have set up that is meant to implement my RAG pipeline here. And you can see I have my main file right here where I can kind of start getting my context. And then notice I also have a Gemini.md file, and this is pretty much my base context for Gemini. And so how that works is you can just look at it right here. So what it looks like is just like
a base prompt. So for whenever I'm like in the directory with the Gemini.md file, it's always kind of, the model's always kind of just like checking back with this, making sure it's following these requirements. So I have like a lot of workflow stuff. I have an overview of what I want it to work on. I have some core components, and then also some tools and some instructions on how to run things. And so it's pretty useful to have that. There's also something called a system prompt that most agents have, and that's like, if this were to be like project by project instructions, the Gemini.md, the system prompt would be like the agent's OS. Like this is like its core directories that whatever company built it like really wants it to do and emphasize. So yeah. But anyways, so I'm gonna run my main file here, and I'm not in my Vim, so that's very important. Make sure we're doing that. And now it should be working. Here we go. And so now I'm just giving it the context. So right now I'm having it prompt me what context to feed my LLM. So if you saw over here, I am in my BreadMaker front end directory. So I'm going to go to projects, BreadMaker front end. Looks like I typed it in wrong. I didn't type the S on projects. BreadMaker front end. Here we go. So now it's already has all my information vectorized, so I can just directly prompt. And so let's say I want to reference, I have a function called snap points, which is pretty much using a coordinate system to kind of snap different icons to a grid. And I want to take a peek at that. I want to have the AI write a function. So I'm just going to say, okay, take a peek at my snap points function, suggest improvements. So here we go. Now it's retrieving. And we can see right here, it retrieved my snap points function, a ton of it, and it's also got some context over here. So look at all this context, and it's also just giving me some framing, right? So it's very important to give an agent and an LM identity, and so it's doing all these things. And so now, ideally, I want to just copy paste this right into the command line interface right over here. I'll just copy paste for now. And we're going to do all this, and Gemini can handle it as a context window of 1 million tokens. So that's 10 times the size of ChatGPT-5's context window, and it's pretty impressive. There we go. So we'll hand it over, see how it handles it, and see what's up. But yeah, just general things while it's loading. I honestly think that the latest models from OpenAI, the latest models from Anthropic are a little bit better than Google's Gemini. But at the same time, this is free. All those other models are paid, and this is insane. Like, and honestly, a RAG for this good of a model might be a little bit redundant, because you can see right here, it can go in and just read my files, right? So I'm giving it all this context, all this code I already have, but at the same time, it can go in and read, and this is just helping it read. Like, this is just the more context you give it, doesn't matter if it's a little bit redundant, the better. As long as it's accurate, it's going to be good. So yeah, so now it's just working on modifying it. We'll just let it cook in a bit, so we'll cut to that. Okay, yeah, so it finished processing. It's just like 30 seconds later, and so you can see it's helping with that. It's getting the snap points function from within my project, and so this is kind of like how I mentioned, it might be a little redundant in this, with this powerful and this kind of involved of an agent to give it that much context with my RAG pipeline. But at the same time, I gave it exactly what to look for, right? So it found the function snap points, it read it, and then it has all this other context that it knows that I want it to consider because I gave it to it. And so now it's improving some suggestions, right? And then what's really cool is like it actually is just going to edit it and change these. And I'm not going to do this because the function actually works fine as it is. I don't want it to change anything, but I'll just have it suggest. Here's all its suggested stuff. It looks like it's taking out some comments, adding some better comments, and just like kind of simplifying some of my logic. Just looks like it does not like that at all, but you can see how this is very, very powerful, because I didn't have to go into any of my pretty large folders. Here is this right here, to copy paste this manually. I could just type my question in right here, get it all, paste it into here, and go from there. And if I really wanted to, I don't even have to go over here at all. I can just have it write directly to the file, I think it wanted to change this last block right here, and I could have just had it change that instantly. And so just something very powerful when we kind of start combining all these tools and really getting the most out of our AI.